Hello, today we're going to talk about solving trigonometric equations. Let's look at the first example. It says solve 4 sine squared theta minus 3 equals 0, where the domain is from 0 to 2 pi. 0 to 2 pi represents the entire unit circle in radian form. So first, let's solve for sine. To do that, we can isolate sine theta by adding 3 to both sides of the equation. And now we can divide off the 4 on both sides of the equation. So we're left with sine squared theta equals 3 over 4. And now to isolate sine, to get rid of the square, the opposite of a square is square rooting. So we're going to square root both sides of the equation. And when we do that, we have sine theta equals, when you square root an equation, it can be plus or minus that value. And then when you square root a fraction, that's the same thing as square rooting a numerator and a denominator separately. The square root of 3 is just square root of 3. But then the square root of 4 is 2. Now, to evaluate sine, we want to find all the values on the unit circle between 0 and 2 pi that are equal to positive square root of 3 over 2 and negative square root of 3 over 2. Remember that sine theta is the y value, the y coordinate. So if we come over to the unit circle, pi over 3 is square root of 3 over 2. 2 pi over 3 is square root of 3 over 2. 4 pi over 3 is negative square root of 3 over 2. And 5 pi over 3 is negative square root of 3 over 2. So theta is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that is the solution to this first problem. In problem number 2, we're going to incorporate the factoring method. This is cosine squared theta plus 3 cosine plus 2 equals 0. Let's think about this instead of cosine if it would have said x everywhere there was a cosine. So that would be cosine squared plus 3x plus 2. Remember, to solve a problem that looks like this, we can apply the factoring method. 2 factors of 2 that add to give you 3 would be x plus 2 and x plus 1. So if we come back and instead of saying x, we plug in cosine, since it says cosine squared, not x squared, that would factor to cosine theta plus 2 times cosine theta plus 1 equals 0. Now, just like before, to solve, you set each factor equal to 0 and solve. So I can come down here and say that cosine theta plus 2 equals 0 and cosine theta plus 1 equals 0. If I solve for cosine, I have cosine theta equals 2, negative 2, and cosine theta equals negative 1. Now, on the unit circle, remember that cosine, the max value it goes, the y value is 1, and the bottom value, the lowest value, is negative 1. Regardless of if you're going to the left or to the right or up or down, the highest value is 1 and the lowest value is negative 1. So therefore, negative 2 is not within that range. We cannot include negative 2 in our answer. It doesn't exist. Well, cosine theta equals negative 1. Cosine theta is equal to negative 1 here at pi. Theta equals pi. Now, let's look at example number 3. 2 sine squared x plus 5 minus 7 sine equals 4 minus 10 sine. The domain is from 0 degrees to 360 degrees, so that's still our full unit circle, but this time our answers should be in terms of degrees instead of radians like the previous two. So the first thing we want to do here is try and get everything to one side of the equation. Since I have a squared here, I want to try and get one side equal to 0 so that I can factor and solve. So to do that, I can subtract off the 4 and add the 10 sine. So now I can combine like terms. So I have 2 sine squared And then negative 7 sine plus 10 sine is 3 sine. 5 minus 4 is 1 equals 0. Now, if I factor this, I can use the same method as I did in the previous one. If I were to replace everything with an x here, 2x squared, everywhere I see a sign, 2x squared plus 3x plus 1 equals 0. Let's try to factor this and solve. Well, when I factor where a does not equal 1, I use what's called the x method. So I'm going to draw an x. And then what I do is I say my a times c up at the top and my b value at the bottom. 2 times 1 is 2. My b value is 3. Two values of 2 that add to give you 3 are 2 and 1. And so then what I do is I divide by my a value. My a value is 2. 2 divided by 2 reduces, so that's equal to 1, which means that this would factor to x plus 1. And then for bottoms up, the 2 comes up for the next factor, so I'd say that's 2x plus 1. So now, instead of saying x, I can plug back in the fact that it's sine and say that that factors to 2, and say that that factors to sine x plus 1 times 2 sine x plus 1 equals 0. And so now if I set each of my factors equal to 0, I have sine x plus 1 equals 0 and 2 sine x plus 1 equals 0. If I solve for x in the first one by subtracting off the 1, I have sine x equals negative 1. And on the second one, if I subtract the 1, I have sine x equals negative 1. But then I have to divide off the 2, so sine x is equal to negative 1/2. So I'm trying to find the values of sine that are equal to negative 1 in terms of degrees. So let's check this out. Sine x equal to negative 1. Remember, sine is the y value. The y value is negative 1 at 3 pi over 2, but remember we want our domain in terms of degrees. So in this case, I would say x is equal to 270 degrees. And then sine is equal to negative 1/2. The y value is negative 1/2 at over here at 210 and down here at 330 degrees. So that means we have 270 degrees, 210 degrees, and 330 degrees. All right, let's check out our final problem. Here we have negative square root of 2 cosine cosecant theta equals 2 cosine theta. Again, when you have a problem like this, you want to get one side equal to 0. I'm going to add the square root of 2 cosine theta cosecant theta to both sides of the equation. And so I have, if I add these, they are not like terms. So I'm going to write, as I see, 2 cosine theta plus square root of 2 cosine theta cosecant theta. Now, if I look at this problem, both terms have a cosine in common, so I can do the GCF factoring here. Greatest common factor. The greatest common factor here is cosine. I'm going to factor out a GCF of cosine, and if I factor out a cosine from a 2 cosine, I'm left with 2, because factor is like divided out. Plus, if I take out a cosine from square root of 2 cosine cosecant, I'm left with square root of 2 cosecant. Now, both pieces are factored, so I can now set my factors equal to 0 and solve. So I have cosine theta equals 0. And then I also have 2 plus square root of 2 cosecant theta equals 0. If I solve for cosecant, I can subtract off the 2. And then divide off the square root of 2. So I have negative 2 divided by square root of 2. Now, what you can do is cosecant is the reciprocal of sine. So that means this is equivalent to sine theta equals, well, if I take the reciprocal of cosecant, then I need to take the reciprocal of the fraction. The reciprocal of negative 2 over square root of 2 is negative square root of 2 over 2. Now, if I evaluate that, theta, sine theta is equal to negative square root of 2 over 2 at the y value of 7 pi over 4 and 5 pi over 4. And then remember, theta also, we have to look at where is cosine equal to 0. Remember, cosine is the x value. So cosine is 0 at pi over 2 and down here at 3 pi over 2. So therefore, theta is pi over 2, 3 pi over 2, 5 pi over 4, and 7 pi over 4.